Hope everyone had an awesome day. We had some really awesome engaging sessions. Our last session of the day is titled Human-Centric AI, Knowledge as an Asset, and I'm joined by Mason Glidden, who's our Chief Product and Engineering Officer at Tulip, Patrick Hyett, the Chief Executive Officer at PLVS Ultra, and Carl Lewis, Senior Director of Strategic Partnerships at Landing AI. And I will kick it over to Mason to get us started.
Perfect. You want to start with a little bit more intro? Patrick, you want to talk about your background?
Yeah, sure. So, hi everyone, I'm Patrick Hyett. It's a pleasure to be with you. So, I'm the CEO, co-founder of a company called Plus Ultra, which is a semantic knowledge graph solution company. Before that, I had 30 years experience with GSK. So, split out into 3 decades. The first decade, I won't bore you with everything, right? I'll keep it simple. The first decade was engineering, design and operations. So developing new products and getting them into new product introduction. The next decade was about putting new platforms in across our entire R&D organization to be more quantitative about the way we developed products. So SCADA systems, data acquisition systems, historians, MES systems, PAT systems, etc. And then the last decade was all about disruptive digital innovation. So I led digital innovation for development and the global supply chain within GSK, led a series of digital innovation programs which led to a lighthouse, a World Economic Forum lighthouse in 2018. And then I developed the strategy with my team for Smart Manufacturing 2030, the business case for it, and initiated the CMC and MPI program and got that off the ground. So yeah, we'll get them up.
Thanks for being here today.
Yes, thank you. My name's Carl Lewis. I'm with Landing AI. I've been with the company now for about 3 years. So I'm responsible for the relationship with Tulip. We have built a great integration with Tulip over the last year or so. So my background is in automation. I did my first computer vision project almost 30 years ago. So hopefully I can pass on some of that knowledge during this session. So good to meet everyone.
Thanks for being here today. To get us started, let's talk about the elephant in the room a little bit, ChatGPT and LLMs. I feel like you can barely open up a newspaper these days without hearing about how ChatGPT is going to take all of our jobs and change everything. Patrick, what do you think about that? Where are results matching expectations here?
I think it's fair to say we are in the peak of inflated expectation.
Yeah.
Maybe starting to move down into the trough of disillusionment. That may be a bit harsh, but I think if you look at the literature and some of the papers that come out so ahead of this chat, I was just looking through some papers that I had, and I was reading some of the stuff that was published in January of this year, and then I was looking at some of the published materials from July, and there's a very different set of use cases. So we've learned, right? We've definitely learned what is working, what isn't working, and I think organizations as a whole have a better understanding of the limitations of some of GenAI and the LLMs that we're using. I think we're starting to see really good use cases. So use cases associated with in pharma and life sciences that certainly around SOP harmonization, translation. I mean, the key's in the word generative, right?
I was going to say, yeah, right.
It's like, it helps.
We're starting to see some of these actually come to fruition. I think back a year ago when we were here launching Tulip's first Copilot features, and we had looked at like, okay, what's the trend of how these models have grown in the past year? And everybody was so excited to see that trend continue. And then like very quickly we hit a plateau.
Yeah.
Right?
Yeah.
And that's where we're starting to see this maybe like slight disillusionment. We haven't kept up with that pace of innovation. At the same time, you're right, we're starting to see these actual use cases and this actual value come through.
And I think we're starting to, I think as translators within our organization, we're able to explain where we are today and also point to what will be possible in the future. And I think more people are getting into this world of saying, actually, you need to combine certain technologies together to get the accuracy that we need if we're going to go after a very specific use case. I mean, one of my team said something, it really resonates even now, and they said, you know, when I read the output of GPT linked to a scientific organization, it's like it's a generalist, not a subject matter expert. And that's a really good way to educate folk in the organization, in a life science organization. It's very different in different organizations,
sure.
but that's a key way I help to explain to people the capability that we have there.
Now, you know, AI, we often used AI as a shortcut for like LLMs and generative AI over the past year or two, but Carl, how have you seen things change with more of the computer vision side of it?
It's a good question. So just thinking back when I did my first computer vision project, 30 years ago, it was all about rule-based vision, setting up a rule for a particular application, really good for objective applications. And fast forward, 30 years to the present moment, we now are in a position where we can deal with subjective applications a lot better than we could. So with AI, with deep learning, we can solve those really challenging applications that are super subjective. So if I had a sample set of parts here and I gave it to everyone in the room, it's likely not everyone would agree. So deep learning gives you the ability to remove as much as possible that subjectivity. So now, in 2024, we can solve a lot more applications than we could even a year ago. So
I think that's a good way to generalize a lot of what's changed. It's more human oriented. It's no longer black and white. You can deal with more of the ambiguity of how a person processes information or generates text versus just this like, hey, can we classify A, B, right?
Right. And also it's also a lot more accessible to everyone. So the company I work for, Landing AI, our objective is to make AI accessible to everyone. So our computer vision platform gives everyone the platform to get started quickly. So if you have a use case that is causing you a challenge in your business and you want to remove that challenge, you can get started quickly without having a knowledge of machine learning or AI. You can get going, pretty fast.
Patrick, over your experience here, how have you seen pharmaceutical companies change the way they approach data and AI?
Well, I think that it's interesting because it's really weird. It's like, so in most big pharma organizations or life sciences organizations, there'll be a strategy around a data lake. And fundamentally, there'll be a user group that are looking to drive data analytics use cases and advanced analytics use cases from that. But one of the things that I've heard time and time again is like, why can't I get the data? Why can I not just have the data that I need, right? So it's really weird that they've gone from saying, why can't I have the data I need? You've got that data lake over there, but I can't get at it, to saying LLMs are going to solve my problems. Do you know what I mean? And I think what's really important is just to come back and answer those questions. Why can't they? Well, the reason is because fundamentally the data lake strategy is born on creating data products that are SQL created. The common data model itself is an incredibly difficult thing to do, using thousands of lines of code to be able to pull various use cases together and harmonize that from a data model perspective. And three, there's a long time. It takes a long time to actually go through and build that. So really, the way I look at it is we need to solve some bigger questions, right? So it's like, okay, if we've got fundamental problems with the cost, the ability to actually deliver in time, and the faith in a common data model will work in order to get over here where we want to solve these data problems, then we need to do a couple of things. The first thing we need to say that we need to find a different way to drive standards. right? So, and fundamentally, the only standard that I can think of is that we will never, ever achieve standards in data from an enterprise perspective. So any solution needs to have that in its heart. You're not going to hard code that problem out, right? If you do, it will cost hundreds of millions and take 10 to 15 years probably.
You'll probably get to the end and find out you made a mistake and did it wrong anyway.
Well, yeah. How can, with that methodology, how can you answer unanticipated questions if that design of code is basically linked between a translation of a business analyst and the developer of that data pipeline? So that is fundamental. That's one thing to solve. And the other is how can you, if you assume that the data is going to be non-standard, how can you develop a set of ontologies that enable you to build a system super fast and make allowance for that error?
Yeah, it's interesting. We've seen customers start to change the type of data they're collecting. Oftentimes, detailed error reports or defect reports end up in this kind of gray zone of unstructured data. Sometimes it's multilingual. And it can be valuable information, but it's hard to mine and get access to.
Yeah.
And some of the changes recently in LLMs have made that data more accessible. And now all of a sudden we see our customers changing what they're recording because this used to just be waste data, right? It would go in somewhere and no one would ever look at it again, into actually a valuable source of improvements that they can find.
I think that's the thing with Tulip that I find quite interesting is as the maturity of being able to assemble data that is readily usable across an enterprise. I'm not just talking about within a silo like an MES system or something like that. I'm talking about across an enterprise, linked data to explore multiple use cases that affect the business operations like CMC MPI, the new product introduction. Things that are on the critical path for the organization as a whole. As you make the right level of progress of stitching LES, MES, and all of these different systems together and be able to use that data, you realize the gaps.
Yeah.
And so many of those gaps are within a context space at the shop floor. And so there's a great opportunity. It's like cyclical. You need to be able to collect and integrate the enterprise data to highlight what really is the gaps.
Yeah.
And the business case associated with what you've connected will actually drive the need to really put the foundational systems in and drive better coverage of data in the shop floor.
Yeah. Coming at that from the computer vision side, Carl, how do you see people collecting data and trying to understand that side of it?
Great question. So I think this is part of the beauty with the integration with Tulip. So assumption is that a Tulip user wants to get more data and do something with it. So with the Tulip integration, we can get images from different types of devices. We can label images. We can train models all within Tulip. So it means computer vision is more accessible than ever before. And you don't need to write any code. You just acquire an image, you label it good or bad, you train your model, and you deploy it. We have a demo running over in the Tulip building. It took me a couple of hours to build the demo, right, with no code. So it's accessible to everyone now. You don't have to be an expert. Anyone on the shop floor can do a computer vision project now.
Yeah, I remember not that long ago a couple of years ago trying to set up a Cognex camera. And it took me like a week to figure out its settings, and then I moved it to a new room and the lighting changed and the model broke. Right, it was like really fragile, and I did need to be an expert in order to properly set that up.
Right. So you don't need to be an expert in writing code. You don't need to be an expert in imaging techniques. You just follow the prompts on the screen, and you can have an application running in a couple of hours.
Yeah.
Yeah.
Patrick, do you see certain like computer vision applications that you're looking at in pharmaceuticals?
Absolutely. I mean, to the point that was made, democratized, right? Yeah. It's far different to how we did when like the projects that we executed in like back in 2017. I can think of one, and the only way it was based on collecting a whole bunch of images around a certain assembly operation which was failing. and then we compiled those and did some deep learning on it, and I think what was interesting about that use case is that the only reason why we were able to actually demonstrate value is because we kept a human in the loop and didn't push that technology too early. So fundamentally, the operator, it would flag up a possible issue with one of these assembled devices. It'd say, we think that, and they would score it, right? They would say, with their expertise, they'd be going, yeah, this is an issue. And then that would help refine and build the model. And initially, that wasn't a validated. It wasn't a validated GXP use case because we delivered it as an advisor, and it wasn't effectively making decisions for that batch. It was just a building a model, and then we used that data. Once that had been generated, and we had that as another training set, then we were able to formalize it in a bit more detail. So I think that was back then, and then you're talking about what you're doing now, and I think I think we still need to keep an operator in the loop in some way, shape, or form. But technology moved on, and what we needed to do to get that up and running was a bit crazy, and it's a lot more beneficial now to use the tools that we've got.
And I would say for those that have not done a vision application before, this is the first one. Try not to pick the hardest one first, right? Be selective of use cases, look at complexity versus business impact.
What makes it harder or more complex?
The temptation is to pick the biggest impact. So, if you're looking at complexity, it's not just the vision system. It could be, adding lots of other technology, combining other technologies like robotics, vision, motion control, right? Then it starts to turn into a system, which increases the complexity. But yeah, that system could cost, quite a bit of money, but it may not be, the simplest one to get started to build the confidence inside the company, bring everyone into the, into the process. So I would say for those, looking at the first computer vision project, pick one with, some in the middle, right? Complexity versus payback, and try to, bring everyone into the, into that process of, building trust in your company, and then move on to something a little bit more complex.
Patrick, you were talking about how to keep the human in the loop and help them and identify things for them. And I've seen that as a strategy in general with AI for validated use cases of how do you help the person do their job without having to make sure the model is 100% correct. Do you see the parallel? You can talk about the parallels there to LLMs as well that we're seeing.
Yeah, I think there's definitely a parallel. I just think that the LLM discussion and the use cases that are appropriate, they're so varied, right? They're so varied. But as I said before, in a pharmaceutical or life science use case, it's often like a co-pilot advisory or a first generation draft or a drift indication, or that's the extent of where we can get to with a lot of the technologies, and we're not going to close loop in decision making anytime soon, unless we do start to think about taking LLMs, combining with graph RAG potentially and other technologies, stitching together a way of getting a lot more context associated with the data that you have, building that, and then building these technologies on top of that. That's the route to be able to get a much more non-hallucinatory output from this technology. So that's what we're advising our customers is the importance of being able to add context. That helps the queries. If you've got 126 tokens, K tokens, you're going to be limited to the ability of an LLM. So it's all about adding the context at the right place while the technology is at the stage it is.
Yeah, it makes a lot of sense. We were looking at some LLM applications for generating G code on machines recently.
Yeah.
And the models were terrible out of the box, right? They didn't know enough about whatever Siemens controller to be able to do anything. But once you started giving it more context, hey, here's some examples, here's good, bad, etc., suddenly these models start getting a lot better. Not good enough to run unsupervised, but enough to at least get that process going.
I was reading something the other day. I don't know if you read it as well, but there was this. It was like a trial they did, they did. It was 600 developers, software development company, and they had 600 developers, and they did 3 months of monitoring their output before getting a co-pilot, and 3 months afterwards, and this is just it's not a kind of, dumbing down the power of LLMs and GenAI, but it's just a warning, right? At that time when that was performed, it's 64% increased errors in code.
Increased with the Copilot.
Yeah, with the Copilot, and one of the statements was, do you know what? It's taking longer to understand and diagnose and debug the code from scratch than it would be to actually write it again.
Yeah.
So I think that's interesting, right? Too heavy reliance on something. But if you had a different dynamic there is if you had a new starter in the organization, and they were using that technology to get on the rung of their development, they'd be flying, right?
Yeah.
But if you give it over to a group of people and they rely wholly on it, that's a very different scenario, right?
Well, I think that speaks to some of the use cases that work best for it almost as a discovery tool, right? I see a lot of parallels to what everyone was thinking about Wikipedia back in 2004, right? Everyone was like, people are citing Wikipedia and they're getting everything totally wrong. And eventually we learned that you don't trust Wikipedia, you read it as a summary and then you click the references, right? And some of these LLMs are actually proving to be a similar, just more powerful version of that. Get a summary, follow it through, and understand where it's pulling that information from.
Yeah.
And then just bring back to the computer vision. So for us, we train our models on domain-specific images from the specific use case. So we're not scraping images from the internet, right? Of dogs and cats. We're inspecting real product. So we're using customer data to create our models. So absolutely true. You can get an open source model on the internet, absolutely true. I think one of the things that sets Landing AI apart, and with the integration with Tulip, is that we use customer-specific images, so of your specific parts, but then also understand the full subjectivity of the application. And then through our platform, we can build that model, right? And that increases the accuracy that you can achieve, and you can deploy it, super fast with Tulip without writing any code.
Yeah.
And it's domain specific to your specific use case.
So it's only just for you. You're not cross-training, but you're building a model for one.
Correct.
Yeah.
With your own images.
Yeah. I think that's a critical aspect of the security of all of this as well. Of your data is super valuable. It's your secret. It's your proprietary information. How do you keep that isolated and just providing value for you, not for OpenAI or whoever else might be training your data?
One of the thoughts I also had. So one of the things we do quite often is to understand that subjectivity. We'll just mount a camera for a period of days. It could be a month, just to understand the full subjectivity. So we have a full image set that represents a month of production. So now we can build a model using that domain-specific data. So that means that when it goes into production, it's going to be much more accurate than just using a few images scraped from the internet.
So is that your usual advice for customers? Start by collecting information, by collecting the data for a while, and then build a model.
Right. It all starts with the data. So it could be that you already have an existing system that may be giving you okay results. Maybe it could be performing at 80% accuracy that you want to get better. Could start with that data, or you're starting brand new, which would mean mounting a camera in manufacturing to acquire, that image data for a month or a week, whatever the case may be.
And so, Patrick, going back to the parallel for you that you're talking about gathering context and trying to capture all that information, for a manufacturer looking to start thinking about this and start moving towards these new AI models, what would you recommend they do today?
I mean, I've alluded to it. I think one of the things is understand the current data situation and really try and think about ways to surface data not in the right way. If there are non-negotiables in terms of context, understand what they are and fix them. It's the first thing. The second thing is really try and understand, before selling a use case, really understand the data. Give yourself some time to understand the data. The amount of use cases I've seen in root cause analysis are where people feel that they can solve those complex problems without very well connected data, just by looking at some non-structured data in like a PDF output. That's a minefield, right? So you have to be careful. I mean, one of the examples that I'd give is typical machine readable PDFs should be available, right? You just think they're available. Excellent. We've got a whole Viva documentum system. It'll all be there. Well, guess what people do? They do a few annotations and they'll sign on the final document, and then they'll take a photocopy and record that, not the PDF, right? So then you try and pull all this data into a use case, and it becomes incredibly troublesome. And inevitably, you're going to have a human need to actually do the final verification if it's a GXP use case. So the thing. I see it as we're responsible for the translation of the technology capability.
Yeah.
And I think to do that, you have to understand deeply what your data sets look like, how you obtain them, the practicalities of it, and make sure that you make it very clear what doesn't exist in terms of non-negotiable data and get it fixed.
Yeah, that makes a lot of sense. Let's look a little bit further into the future. Carl, what do you think things are going to look like in 10 years around all of this?
It's a great question. We're doing a lot of work on vision agents and the idea of multiple vision systems working together to identify root cause. So
multiple cameras all looking at the same thing?
But also being able to train a vision system. Could be through voice recognition, just using the prompt. But yeah, multiple vision agents working together to solve a problem. So it could be, using different imaging technology to maybe, zoom in on a feature, to accentuate a feature, and just removing the human element from the equation and doing that automatically.
Doing more complex analysis and things like that. Interesting. Do you think some of that will also be suggestible in the future, or is it still going to require a person being like, okay, I'm going to set up 10 cameras and this one's going to be a 12x zoom and et cetera, et cetera?
It's a good question. I mean, assumption is you're always going to need some kind of hardware to create your contrast in your image. As long as you have your contrast, you can do something about it. But manufacturing is there's so much variation, especially if you're bringing a new product to market, you've got that periods where you're trying to understand your process and iron out different elements of your process. That's where the subjectivity is. So how can you shorten that subjectivity window? And that's one of the things that we're working on right now.
Makes sense. I'm also really interested in how to take the output of a model like that and feed it back into the rest of the process. Take something like computer vision, take the output of that, and then go make changes to your process automatically based on what you're observing there. And starting to combine together multiple of these models together.
Right, yeah, so multiple models together, using LLMs, using a vision model, feeding that data back. And also there's the other element of how can I continuously evolve and retrain my model without a human in that loop, right? So it's about how can I add more image data to my training data, so I'm constantly improving the performance of my model as the subjectivity increases, and doing that automatically. So that's something we're working on right now.
Patrick, what do you think? What's the shop floor of the future look like here?
Well, what I'd like to do is kind of talk about vertical and horizontal integration as it pertains to the shop floor. So I think we have a technology now to quite easily be able to integrate, like in a life sciences organization, MERP data, MES data, LES data, process data, notifications, and so on, both structured and unstructured. That's not necessarily via GenAI, but other technologies, so that exists. So that gives you ridiculous possibilities in terms of being able to understand from what you've done what is optimum for a product, for a unit operation, for a site. You can cut it up in many ways just by
More automatically process and understand huge volumes of data.
absolutely, and with rich context. So why can't you ask a question on what this particular batch, this single batch that has this performance, where does it sit in relationship to 500 other batches, etc. What's the drift across all materials or all batches, etc. So, like, if you've got that, right, bear with me.
Yeah.
If you've got
I understand so far.
Right,
yeah.
cool. Then why wouldn't you be able to start thinking about performance at the shop floor and influence decision making at the shop floor in terms of drift or in terms of potential performance challenges or in terms of improving performance? And then, we're here at Tulip HQ or just across the road from it. So why wouldn't you be able to use those type of shop floor user interfaces to route deviations in real time, solve problems before the batch is completed?
Yeah.
So you've not only got this is the concern of the batch, but this is how to solve it. This is how to route that workflow through QA, get sign off on it, and have it dealt with before you even need to sanction the batch.
Yeah.
That's not a 10-year plan. That's a 1 to 3 year plan. So exciting times. And like you talk about Gen AI. I mean, if there are technologies like Mamba that are in development that are trying to solve the whole 128K, 26K.
Not familiar with Mamba.
So Mamba are a company that are looking to basically sequence from left to right effectively. Okay. So left to right, and gain a level of understanding of context as it goes through, rather than you having a fixed box of query statements that you can use, and it'll be used up. So you have an infinite
rolling window style.
Infinite more level of ability. So you're basically the hallucinatory aspects of your LLM will go if that type of technology is. So that would be the next stage of it.
Interesting. Yeah. I'm really interested in the sort of closing the loop side of it, right? Being able to join all of these signals together, whether it's a set of images and pictures taken from the shop floor, or signals coming from a machine, or people typing something in, and synthesize that together towards, as you mentioned, a real-time alert, or going and changing your process, right? Hey, look, we noticed all of this common type of defect happening in these images. How about you go and change your process here to catch that earlier and do something about it, right? That discovery process is half the battle. But
definitely.
As we think towards that sort of future state of all of this, what teams, who needs to get involved, who needs to be thinking about this?
I would say everyone should be involved. I mean, it's such a big undertaking, right?
Yeah.
I mean, any transformation needs everyone involved, and that's from the user right up to the CEO of the company, because it's a transformation, and if people are not involved in that journey, that can be a challenge, and it creates resistance, and it takes a lot longer than it should. And technology can be, especially AI, there's a lot of hype. It's often misunderstood, but especially in a computer vision context, if it's applied in the right way, at the right time with the right resource, then you can achieve a lot. And the demo that we have in our booth, as I said, it took me a couple of hours to have a a deployed production-ready solution, with a 99.7% accuracy. I'm not completely satisfied with that.
Wish we were 99.99.
99.99 is the goal, but it all starts with the data. If you have a good set of data, clean image data with a lot of visible contrast, you can create a high-performance model and get it ready for deployment on the shop floor in a couple of hours, and you can do that at scale, since it's cloud-based.
Getting it in the hands of the person closest to the problem, so they
Right.
can handle it instead of it, being somebody off on the, at Landing AI doing it and having to deliver it to
Right.
you. How do you enable that person closest to the
Right.
problem?
But it should be positioned as a tool to assist and augment, not to replace. That's really the goal, and so multiple people need to be involved in that process.
Yeah, I agree. And sort of think about how do you bring together IT, OT, and innovation together into one.
Right.
Any one group that's going to try to push it isn't going to get the traction or understand
Right.
the need from the others.
Yeah, there's always going to be that tension between IT and OT if there's if that communication is not done in the right way.
Yeah.
So yeah.
Any thoughts, Patrick? on
I
tech?
mean, I think that's really well covered. I'd just say that I think it's really important just to be really good translators of in a positive way of what the capabilities are today, and don't state the capabilities today, but make sure we really emphasize the practicality of value of the tool set,
Yeah.
and where it's going as well, right? Because this isn't going away. This technology is only getting better.
Agreed.
And more accurate, especially when it's combined with other technologies. So that's what I would say is good translation of information and communication with groups, especially when it pertains to an absolute necessity in terms of regulatory use case.
I think some people's bullshit detectors are up on some of this, right? There's been so much hype over the past 2 years that you say, LLMs, and some people roll their eyes at you or something like that, and
Right.
anchoring it in what can you do today, what's possible today, not, hey, look, it's going to be everything for everybody immediately tomorrow.
Right. And for us, it's we prove it. So yeah, we can show, but we prove it.
Yeah.
That's what people want to see.
Show it today and go from there. Solve the problem for today.
Yeah.
Makes a lot of sense. Cool. Any other, I think that's the sort of main topics we had to sort of cover.
Yeah,
Any other
good.
thoughts or? No?
Good.
Well, thanks everyone for coming today and coming to bearing through the last session here of the day. Next up, we have a reception just across the way on the lawn. We have some drinks and refreshments out there, as well as a band playing for a little bit. Thanks everyone.